Class உடைய continuation பார்க்கிறோம். Torque acting on a rectangular coil carrying current. Previous class பார்த்தீங்கன்னா force acting on a current carrying conductor placed in a magnetic field பார்த்தோம். That magnitude was given by F is equal to BIL sin theta அப்படின்னு நடக்கும். அதில் that particular equation gives the magnitude alone. So for direction, we are going to use Fleming's left hand rule. In what direction the force is acting, for that we used Fleming's left hand rule. The application in next two derivations, we are going to see the applications of the previous class. So torque acting on a rectangular coil carrying current. So now we are going to take a rectangular coil. Our name on the class, so I am going to give the name as A, B, C, D. A, B, C, D on the rectangular coil of length L and breadth B. The length of the coil is going to be taken as small l, and the breadth of the coil is going to be taken as small b. Physics diagrams mark diploma level diagrams specific mark so diagrams draw neat draw derivative part easy understand. So in the ABCD is a rectangular coil of length L and breadth B carrying a current of I ampere. So this is the direction of flow of current. Direction of flow of current. Now the anti-clockwise lo potu. So A, B, C, D. The direction of the current direction is correct. Mention pannirkom. Now this rectangular coil is going to be kept in a uniform magnetic field. So that magnetic field is going to be represented by letter capital B. So previous class itself I told that the magnetic field is always represented by letter capital B. So in new magnetic field capital B. So now the breadth size so this is the direction of magnetic field and this is the direction of magnetic field. Okay, here we final if you apply Fleming's left hand rule or if you see the previous video the current carrying conductor and magnetic field are parallel to each other, then there is no force at the instrument. Theta is equal to 0, the force equal to 0. Current direction magnetic field parallel. That means the ABCD rectangular coil we can divide it into 4 current carrying conductors. AB or current carrying conductor, BC or current carrying conductor, CD or current carrying conductor, AD or current carrying conductor. So all the 4 put together will act as a rectangular coil. This breadth size they are parallel to the direction of magnetic field. The current carrying conductors are parallel to the direction of magnetic field. So the value of force will be 0 in the breadth size of the coil. Whereas coming to the length size, see this AB and CD, the direction of magnetic field and the current carrying conductor are perpendicular to each other. So in the previous video we explained when theta is equal to 90 degree, the force value will be maximum. Now the direction of force will be like this. So if you apply the same Fleming's left hand rule, see right. So this is the direction of magnetic field. Forefinger gives the direction of magnetic field. Middle finger gives the direction of current. So if you apply Fleming's left hand rule here. See, this is the direction of current. Middle finger, previous video I explained stretch the forefinger, middle finger and the thumb of your left hand mutually perpendicular to each other. The middle finger gives the direction of current, forefinger gives the direction of magnetic field, and the thumb gives the direction of force. And the previous video I explained force in the direction of so in 3-dimensional imagine that force is acting perpendicular to the plane of the blackboard and outwards. Okay, in the explanation part you correct catch money. In the if you apply Fleming's left hand rule, so in the AB explain CD explain Fleming's left hand rule the direction of force will be acting perpendicular to the plane of the blackboard and inwards. So final conclusion there is no force on the left sides of the coil, whereas in the length sides two equal forces are acting in the opposite direction. Two equal forces are acting in the opposite direction, so it will constitute a torque. Rotate and the torque value is derive heading torque acting on a rectangular coil carrying current. So in the diagram the force value mentioned F is equal to BIL. The value of force equal to BIL. So two equal forces acting in the opposite direction constitute a rotating torque. Now in the rectangular coil, for example, I am going to explain with this book. So this is the rectangular coil. So A, B, C, D. Assume the top portion AD and the bottom portion BC there is no force whereas and the length sides two equal forces are acting. One towards you. Suppose you class assume one force is acting towards you, and the other force is acting towards the blackboard. So when two equal forces acting in the opposite direction, then the coil will rotate. So that is the meaning of torque. So you imagine this book as a rectangular coil. So back sides there is no force, length sides two equal forces acting in the opposite direction, which will make the coil to rotate. So for that we are going to give the derivation. Okay, in depth this concept is going to be used in the next derivation called as, or next explanation called as moving coil galvanometer. Okay, now I am going to explain whatever things I already explained the fact. Now I am going to write it in the notes format. So ABCD. So the explanation part is already explained. Now this diagram is explained in the form of words. See, ABCD is a rectangular coil carrying a current of I ampere. Kept in a uniform magnetic field. The diagram is the words in the compulsion own version own language meaning change represent whether it is in Tamil or in English. Tamil ABCD என்கின்ற ஒரு செவ்வக வடிவச்சுருள் B என்கின்ற சீரான காந்தப்புலத்தில் வைக்கப்படுகின்றது. அதன் வழியே செல்லக்கூடிய மின்னோட்டத்தினுடைய அளவு I என்று எடுத்துக் கொள்ளப்படுகின்றது அப்படின்னு சொல்லி சொல்லுவோம். Then நம்ம ஆல்ரெடி சொல்லியிருக்கோம் L is the length of the coil and B is the breadth of the coil. L is the length of the coil and B is the breadth of the coil. Third point, இங்கே தான் நம்ம அந்த கான்செப்ட் குள்ள போறோம். Already I explained the breadth size of the coil are parallel to the direction of magnetic field. பாருங்க, the breadth size of the coil magnetic field க்கு parallel இருக்கனால force 0 சொல்லியாச்சு. Because when theta is equal to 0 in the equation போடுறீங்க F is equal to BIL sin theta theta 0 போட்டீங்கன்னா sin 0 0, so the force will become 0. So now direct as the breadth size of the coil or parallel to the direction of magnetic field, the value of force equal to 0. Then coming to the length size of the coil, the length size of the coil are perpendicular to the direction of magnetic field, so they will experience a force. So same equation, F is equal to BAL sin theta. Here theta value is equal to 90 degree. So the force, if you substitute theta is 90, sin 90 equal to 1, then the value of force F is equal to BAL. அதான் இங்கே டயக்ராம்லேயே போட்டிருக்கேன். லெஃப்ட் சைடு ஆஃப் த காயில் ஏபியில் ஒரு ஃபோர்ஸ் ஆக்ட் பண்ணு, சிடியில் ஒரு ஃபோர்ஸ் ஆக்ட் பண்ணு. ஸோ டூ ஈக்குவல் ஃபோர்ஸஸ் ஆர் ஆக்டிங் இன் தி ஆப்போசிட் டைரக்ஷன். பாருங்க, the length size of the coil are perpendicular to the direction of magnetic field. So the force value is F is equal to BIL. So two equal forces acting in the opposite direction constitute a couple. So அந்த couple சொன்னாலும் ஒன்றுதான், டார்க்னு சொன்னாலும் ஒன்றுதான். இது ஆல்ரெடி ஃபர்ஸ்ட் செமஸ்டர்ல ஃபர்ஸ்ட் யூனிட்ல we already discussed moment of a force, torque, couple அப்படிலாம் நடத்திருப்போம். இப்போ டார்க்கு என்ன ஃபார்முலா அப்படின்னு பார்த்தீங்கன்னா product of either one of the force and the perpendicular distance between the two forces. So in our derivation part, the value of force is BIL. So either one of the force, F is equal to BIL. Then perpendicular distance between the two forces, again பார்த்தீங்கன்னா இந்த காயிலுடைய breadth. இந்த ஃபோர்ஸ்க்கும் இந்த ஃபோர்ஸ்க்கும் மிடில் இருக்கிற distance, perpendicular distance means that is nothing but the breadth of the coil. So perpendicular distance is substituted as small b. Now if you multiply the length of the coil and breadth of the coil, you will get the area of the coil. So tau is equal to BIA. If the coil possesses n turns அப்படின்னு சொல்லும்போது torque tau is equal to NIAB. N indicates number of turns, I current through the coil, A area of the coil, B is the magnetic field. Suppose உங்களுக்கு கன்ஃபியூஸ் ஆகிற மாதிரி இருக்கு அப்படின்னு பார்த்தீங்கன்னா இந்த ABCD அப்படின்ற ரொட்டேஷன் யூஸ் பண்ணாமல் நீங்கள் என்ன பண்ணலாம் அப்படின்னு பார்த்தீங்கன்னா you can use it as PQRS. ஏன்னா வந்து இங்கே ஒரு A போட்டுரும், area of the coil ஒரு A வருது, then magnetic field is already represented by the letter B. அப்படினால இந்த B-க்கும் confuse பண்ணிக்கூடாது. If you want, you can change the representation as PQRS. So it shows which. So PQRS அப்படின்னு போட்டீங்கன்னா இங்கே மாற்றிக்க வேண்டியதான். PQRS is the rectangular curve. That is the only change. Okay. Now this final equation is going to be used in the next concept called as moving coil galvanometer. Thank you.